In this lesson video, we're going to be talking about geometric sequences and using them in exponential functions. So far we've talked about sequences of numbers that have a pattern. Some don't have a pattern and they're just nothing. But if they have a pattern where we are adding or subtracting by the same amount over and over, we call that an arithmetic sequence. So for example, 2, 4, 6, 8, 10, 12, right? We're adding 2 over and over. 3, 6, 9, 12, 15. We're adding 3 over and over to get the next number, right? -4, -8, -12, -16. We're subtracting by 4 over and over. So we're either adding or subtracting by the same amount. This is an arithmetic sequence. That's bad writing. Arithmetic sequence. So now we're going to talk about geometric sequences, and we have kind of touched on this when we first started talking about exponential functions, right? A geometric sequence is when we are multiplying by the same amount over and over. So you want to think of it as multiplying. It could actually look like dividing, but don't think of it as division. Think of it as multiplying by a fraction, and I'll show you what I mean here. All right, so when we're looking at a sequence, to figure out if it's a geometric sequence and to figure out what we are multiplying or dividing by, we're going to take the second number in the term. Here's the first number. Second number in the term and divide it by the number in front of it. So you take this guy, divide it by the one in front of it. This guy, divided by the one in front. So 63 divided by 21 is the same thing as 189 divided by 63, which is the same thing as 567 divided by 189. And if we actually go through and divide each of these by divide each of these, we get 3. The answer is 3. So if we divided this by 3 to get 21, that means to get to the next number in the sequence moving forward, we have to multiply by 3. Okay, so 21 times 3 is 63. 63 times 3 is 189. 189 times 3 is 567. We're multiplying over and over. If you want to find the number you're multiplying by, start with a number and divide by the number in front of it. That answer will tell you what you're multiplying by in your geometric sequence. All right? The ratios are constant. The amount that we're multiplying by is constant. So the sequence is geometric. And the number that we're multiplying by is called the common ratio. The common ratio. Okay, let's look at another one here. We have -1215. Positive 405, -135, positive 45. At first glance, it doesn't look like there's any pattern here, right? So if we start with the second number and divide by the first, we get 405 divided by -1215. If we do it here, -135 divided by 405. 405 divided by -135. If we actually simplify all of these fractions, they are all equal to -1/3. Okay, so to get from one number to the next, you are multiplying by -1/3. That is the same thing as dividing by -3. So multiply by -1/3 is the same thing as dividing by -3. It's the same operation, so don't get confused there. This divided by -3 is this. This divided by -3 is this. This divided by -3 is this. In geometric sequences, they don't want you to think of division at all. So dividing by -3 is the same thing as multiplying by 1 over -3. Okay, so our common ratio here is -1/3. Multiply each term by the common ratio to find the next 3 terms. So the common ratio is -1/3. 45 times -1/3 is -15. -15 times -1/3 is +5. And again, you can think of it in your head as dividing. 45 divided by -3 is -15. -15 divided by -3 is +5. Positive 5 divided by -3 is -5/3. And now we're just going to get into more fractions. So the next three terms of the sequence are boom, boom, boom. When we actually come up with a common ratio, the common ratio is the number we multiply by. So yes, you can solve by saying, okay, I'm dividing by -3, but when they ask you for the number, the common ratio that you're multiplying by over and over, it has to be multiplication. You can't say the common ratio is -3 because I'm dividing by negative. No, they don't recognize division. So what number are you multiplying by over and over? -1/3. I hope that makes sense. Okay, so let's look at a few here. I'm gonna zoom in a little bit. All right, determine whether each sequence is arithmetic, geometric, or neither, and explain. Explain means show your work. So here, to get from 1 to 2, I added 1. 2 to 4, I added 2. So that's already different. This is +1. This is +2. So I know this isn't arithmetic, because to be arithmetic, I would have to be adding by the same amount over and over. So now I can ask myself, okay, am I multiplying by the same amount? 1 times 2, 1 times 2 is 2. So I could be multiplying by 2. 2 times 2 is 4. 4 times 2 is 8. So it does look like I'm multiplying by 2 over and over. So this is a geometric sequence. And the common ratio is 2. The number I'm multiplying by over and over is 2. Okay, number 2, 9, 14, 6, 11. All right, well, to get from 9 to 14, I can't really multiply or divide by anything. Can I add? Yeah, I can add 5. If I add 5 again, do I get 6? No, I had to subtract 8. 6 to 11 is adding 5. So it looks like there's a pattern. But I don't want a pattern. I have to be doing the same thing over and over. All right, to get from 9 to 14, was there anything I could multiply or divide by? No. 14 to 6? No. 6 to 11? No. I don't recognize anything. So this is neither. This is not arithmetic or geometric. I'm not doing anything the same over and over. Number 3, to get from 2/3 to 1/3, I subtracted a third, right? 1/3 minus 1/3 would be 0. 0 minus 1/3 would be -1/3. So this is not arithmetic. I'm not subtracting by the same amount. To get from 2/3 to 1/3, I can basically multiply by 1/2 over and over. And so you look at that and you say, how do you know that you can multiply by 1/2 looking at that sequence? Well, something stands out to me in the sequence, right? Because it went from 2/3 to 1/3. So 1/3 is half of 2/3. 1/6, so it looks like I doubled the bottom. Then I doubled the bottom again, right? So to be able to double the bottom, I have to multiply by 2. Then this doesn't really fit into that, but there's something going on here, right? So if I take 2/3 and I multiply by 1/2, excuse me, 2 times 1 is 2. 3 times 2 is 6, and then I can simplify this to 1/3. So I took 2/3, I multiplied by 1/2, and I got 1/3. If I multiply 1/3 times 1/2, I get 1/6. If I multiply 1/6 times 1/2, I get 1/12. Right? So I'm multiplying by 1/2 over and over, and sometimes you will have to simplify your fraction. Those simplified fractions are what don't feel like they fit in the sequence sometimes. You just got to ask yourself, okay, well, is that fraction equal to something else that does fit in the sequence? In this case, it would have been 2/6. Okay, so hopefully that makes sense. This is geometric because we're multiplying by the same thing over and over. The common ratio we're multiplying by is 1/2. And then number 4, we've got -2, 5, 12, and 9. It looks like to get from -2 to 5, I added 7. 5 to 12, I added 7. 12 to 19, I added 7. Since I am adding over and over, this is an arithmetic sequence, right? It is not geometric. Geometric is multiplying. Arithmetic is adding or subtracting. Okay, number 5 down here. Find the next 3 terms in each geometric sequence. So you got to figure out what the common ratio is and then apply it. So to get from here to here, I don't know looking at it, right? But I know to figure out the common ratio, I'm going to take this number and divide it by the number in front of it. So negative 216 divided by 648. And I can simplify that. If I change it to a decimal, maybe I can tell. Is equal to 1/3, negative 1/3. So my common ratio, it already tells me it's a geometric sequence. So that's not in question. I'm not trying to determine if they all have the geometric sequence, the same, if they're being multiplied by the same common ratio. It tells me they are. So I just use that. I found it. That's the common ratio. So then I find the next three. So 72 times negative 1/3 is going to be negative 72 over 3, which is negative 2, 6, 12, negative 24. Negative 24 times 1 over 3, negative 1 over 3, is positive 8, because it's positive 24 over 3, and 24 divided by 3 is 8. And 8 times negative 1/3 is negative 8 over 3. Negative 8 over 3, right? So basically I'm dividing by 3 over and over, dividing by negative 3. Negative 24 divided by negative 3 is positive 8. Positive 8 divided by negative 3 is negative 8 over 3. My common ratio, the number I'm multiplying by, is negative 1/3, and that's the same thing as dividing by negative 3. So my answer here, my next three terms, are those three numbers: negative 24, positive 8, and negative 8 over 3. Sorry, that's sloppy. I'm trying to do better. Number 6. I've got 25, negative 5, and 1. Okay, so to figure out the common ratio, I start with the second number, divide by the number in front of it, and I get negative 1/5. Right? So if I take negative 5 and multiply it by negative 1/5, negative 1 times negative 5 is positive 5. 5 times 1 is 5. I get 5 over 5, which is 1. Right? So if I take that 1 and I multiply it by negative 1 over 5, I get negative 1 over 5. And then I want to multiply that by negative 1 over 5, so I get positive 1 over 25. And then I want to multiply 1 over 25 by negative 1/5. So I get negative 1 over 125. Okay, so my next three terms in my sequence are these guys right here. Looks like I'm basically dividing by negative 5 over and over. My common ratio, the number I'm multiplying by, is negative 1/5. So 1 times negative 1/5 is this guy. This guy times negative 1/5 is this guy. This guy times negative 1/5 is this guy. I hope that's making sense. Number 7. 1 over 16 gets to 1/2. What did I multiply by? Well, this is where we can think of this as this. I don't get it, but what if they end up having the same number on the bottom, right? And I had 1/16, and that's like 8/16. And then the next number would be, what, 4 over 16 is 64 over 16? So what am I multiplying by over and over? This times 8 is 8. This times 8 is 64. 64 times 8, right? So this is the same thing as these three numbers, but looking at them this way, it's easier to tell what we're doing. What did I multiply this by to get this number? I multiplied this by 8 over 1. What did I multiply this by to get this number? Multiplied it by 8, right? When I simplify these, they look like this. So what would the next thing be? What would I get if I multiplied this number by 8? This is 4. What's 4 times 8? 32. What's 32 times 8? Well, I gotta multiply it here. 32 times 8, 256. And what's 256 times 8? 2048. That went up in a hurry, right? We started off with this fraction and just 1, 2, 3, 4, 5 numbers later, we're already over 2,000. But our common ratio here was multiplying by 8. So this times 8 gave me 1/2. This times 8 gave me 4. This times 8, this times 8, this times 8. Those are our next three numbers. And last but not least, number 8. Here we go. Looks like we're going down, so we're dividing. Well, we know that when we have a geometric sequence, we don't really think of it as division. We think of it as what are we multiplying by? It's going to be a fraction. So to come up with that fraction, I start with the second term, divide it by the first. 36 divided by 72 is equal to 1/2. So I keep multiplying by 1/2. So 18 times 1/2 is 9. 9 times 1/2 is 9/2. And 9/2 times 1/2 is 9/4, right? 9 times 1/2 equals, this is like 9/1, so 9/2 times 1/2 equals 9/4. Everyone good with how I got that? So these are the next three terms in our sequence. Let me know if you have questions.